Hello out there to you. In this video, we're going to solve for the profit maximizing quantity or the single price that a monopolist is going to charge. We're going to do that by finding profit maximization and the profit maximizing quantity. So what does that mean? So we're going to hear that term a lot in your microeconomics class. Profit maximization means we're going to produce to where marginal revenue equals marginal cost. Now in this particular problem, we're going to figure out what marginal revenue is, but we're actually told that marginal cost is $4. So we know that, okay? Next thing we want to do, we want to figure out what is marginal revenue. So marginal revenue is the change in total revenue divided by the change in quantity, which is a fancy way, so this is marginal revenue. That's a less fancy way, actually, of saying it's the partial derivative with respect to Q of the total revenue function. That sounds like a mouthful, but it's not quite as hard once you do it as saying it. So one thing I like to do is I like to rearrange this demand function to make it a inverse demand function. So I'm just going to rearrange what's going on here so that price is isolated over on its own side. So we're going to go 2P equals 12 minus Q, divide through everything by 2. So I get P equals 6 minus 1/2 Q. This is the inverse demand function. Now, total revenue is price times quantity. Okay, and we actually know what the price is. So total revenue is, I'm going to write it out a little, I'm going to say Q times this function here. So 6 minus 0.5 Q. And that gives us 6Q minus 0.5 Q and then squared. Okay, that little caret means squared. Okay, so now I've got total revenue function. I just need to take the partial derivative with respect to Q of that. And there's lots of videos on how to do partial derivatives. So I'm not really going to show you how to do that, but I'm just going to say 6 minus Q, and that is that's our marginal revenue function. So now you can look at it. I did the calculus here, but if you're dealing with a linear demand function, you can actually just take a look at it here and multiply that coefficient by 2, and that'll give you your marginal revenue function. So you could have done that without any calculus at all, but whatever, I did it anyway. So, okay, so now I've just got marginal revenue equals, I just need to set that equal to marginal cost. So it'd be 6 minus Q equals 4, and we're going to solve for Q. So this comes over here, and that makes it 2. And this is Q. So Q is 2. So now I know that's the profit maximizing quantity. I'm going to plug that in. You can either plug it into the inverse demand function, that guy, or you can plug it into that function. Either way, solve for P. I'm just going to put it in the inverse demand function, 6 minus 1/2. So that would be 0.5. We'll write it out here, times 2. And you get P equals 5. Okay, so they will sell 2 gallons of gasoline, and the price will be 5. It'll be expensive because she's the only gas station around, and that's how to solve for profit maximizing quantity when given the demand function.